In this video, we're going to get a better understanding of special right triangles, where they come from, and how they're useful in trigonometry. First, we start with a regular right triangle, also called an equilateral triangle, where all the sides are congruent and each angle is 60 degrees. Now, if this was bisected with the altitude, then our base now is half of what it used to be. And we'd like to calculate what is the height in relationship to x, which is the length of the hypotenuse. We're going to use the Pythagorean Theorem that is used for right triangles, a squared plus b squared equals c squared, to determine what the length of the height will be. As you can see with the math, the value of b ends up being square root of 3 over 2 times the length of the hypotenuse. This is going to be called our 30, 60, 90 triangle, and now we know the relationship of each side. Next, we're going to look at the next regular shape we know from geometry called a square. If this was cut along the diagonal, we have what's called a 45, 45, 90 right triangle. Using Pythagorean Theorem, a squared plus b squared equals c squared, we want to find the relationship of all three sides. And what we notice here is the hypotenuse is square root of 2 times longer than the leg. Now we want to make these two triangles comparable. So what we're going to do to compare them, we're going to set each of the hypotenuses equal to 1. So with the hypotenuse of 1, I want to find the actual length of each side. So I need to figure out the value of x. Set root 2 times x equal to 1, and rationalizing the denominator, we find that the length of the leg is root 2 over 2. So the hypotenuse is 1, and each leg is root 2 over 2. We're going to want to do the same thing with our 30, 60, 90. Set the hypotenuse equal to 1, putting 1 in for the x and multiplying by each side. So I'm going to take the same triangle, I'm just going to rotate it so the base is my long side and the values stay the same. Now I'm going to look at all three triangles, a flat one with a 30 degree being the base angle, which is pi over 6 radians, the middle triangle, which is a 45 degree base angle, which is pi over 4 radians, and my tall triangle, which is 60 degrees for a base angle, and pi over 3 radians. All of these values are exact with relationship to the hypotenuse being 1. And this should give you a better understanding on how the unit circle is created.